Hello and welcome back. In this video we're going to look at three more patterns used when programming with for loops: the mapped list, filtered list, and counting loop patterns. So moving on to the first of those, sometimes we want a function to receive as a parameter a particular list, and we're wanting to create a new list that is based on that original list, but with each of the elements of the list modified in some way. So for example, we might pass in a list of integer values, and we'll create a new list in which each of the elements is the square of the elements in the original list. Or we might pass in a list of strings, and we'll return a new list in which each of the elements in the list is the capitalized version of the strings in the original list. So let's have a look at a few examples of that. So the first of my examples was creating a new list that is the square of the original, where each of the elements is the square of the elements of the original list. Here's an example. We're going to create a list of numbers. This is just a series of int values, and we're writing a function squares, and the purpose of this is to implement a mapped list pattern that returns a new list where each of the elements is the square of the original list. So nums is the parameter. An argument is going to be passed into this function and received by nums. We have a nice docstring that says it's going to return the squares of the given numbers. The first thing we do in this function is create a new list. So we're creating a new and empty list. That's our syntax for producing an empty list, just open and close square bracket. So result now refers to a new piece of the computer's memory that is an empty list. Then what we need to do is march through each of the elements in the original list. The original list is referred to by nums. So num is going to refer one by one to each of the elements contained in the list nums. And what we're going to do is append to result. So result refers to a list, but it's an empty list at the beginning of this loop. We're going to append to the end of that list the result of computing num times num. So this is going to give us the square of each of those elements. And once it's done it for the first element, it'll do it for the second element and the third and fourth. And then we won't finish going around this loop until we've processed each of the elements contained in the original list. The last thing we do is return the result, and again, result is a reference to a list. So we expect the return value to contain a reference to a list where the list is the square of each of those original elements. So let's run that, and we can see we're expecting two print statements. First off, we create numbers, then we print out the content of numbers, and we see it here. It's exactly the same as the list that we assigned to, as you'd expect. Then we have a print statement that says print the squares are, and what we're doing is passing in as a second argument to the print function a reference to whatever the list is that we produced as a result of calling squares. Okay, and we see our expected result. We can see we've got an element 1, which is 1 times 1 is 1, minus 3 times minus 3 gives us 9, 11 times 11 gives us 121, and 100 times 100 gives us 10,000. So importantly, what we've done here is create a new list inside our mapped list example. And then we have appended onto that empty list the result that we want for each of the elements in the original list. Okay. A second mapped list example, I mentioned returning a string that is the uppercase of the original string. Here's our uppercase mapped list function. It returns the given list of strings in uppercase. And again, we see the same thing. We create a result that is a reference to an empty list. So importantly, we are creating a new list. And then we're going to append to that new list a value for each of the values contained in the original list. So for s in strings, where strings is a reference to the original list that's passed in as an argument, we're going to append to the list the result of calling s.upper. So upper is a method defined for any string that converts that string to uppercase. So we have names, refers to a list that contains Bob, Carol, Ted, and Alice. We print out the original list, and then we print out the result of calling uppercase, passing in a reference to our list of lowercase values. So the result you should expect, we've produced a list that contains the capitalized versions of the original list. Give that a go in your own time. Work with mapped lists. The filtered list pattern is similar to the mapped list pattern, except that it selects particular elements to include in the new list. So it still creates a new list and returns a new list, but it has an if statement contained inside the body of the for loop to select particular elements. Not every element would normally be included in a filtered list pattern. So an example of that would be write a function called negative elements that returns a list of the negative elements in a given list of numbers. So we're not changing the values, the elements in the list here, or we needn't be, but we are selecting certain values to be included in the resultant list. So negative elements receive some data where data is a reference to a list. We start off creating a new empty list, and for each element in the data, if the element is less than 0, we'll append it to the list. So this is the filtering. Only the negative elements are going to be selected for being included in the new resultant list. So we're appending to result that starts off being empty, and at the end of this list we return the result. At the end of this function we return the result. So let's run that. I need to save it first. So I've now done that, and if I run it, there's no output here because I haven't called the function yet. So let's print the result of calling negative elements, passing in a list that is 1, 2, 3, -6, -7, 8, and -10. Okay, so that's just some sample data that I'm passing in to negative elements, and what we're expecting negative elements to do is to produce or return a list that only contains the negative elements. So we should get a list that contains -6, -7, and -10, and none of the other values. Let's see if we get it. -6, -7, and -10. So we've selectively filtered elements from the original list, and we've returned a new list containing only those selected elements. We've already seen an example of a counting loop pattern. Our very first for loop iterated across the integer values from 0 to 6, printing out the squares of each of those values in turn. The range function gives us easy access to a series of increasing values. So for example, here we say for I in range 0 to 7, calculate what the square is, and then print out the square values. So if we run that, we get what we expect, but easily we can change the starting point and the finishing point. So if we want to change the range from, let's make it 10 to 52, there we go, we can rerun it, and we see that in the shell here we've started at 10 and we've finished at 51. So it goes up to but not including the second value. So what is the range object? Well, we can type in the shell 0 to 7. It's actually not quite what you might expect. It's not just a list of the series of values. It's actually returning something called a range object. So it returns something that allows us to iterate over a series of values, but it's not actually a list. And this is different from some earlier versions of Python. So we can type in what is the type of range 0 to 7, and what it'll tell us is that this is a class range. So this is a special type of object that allows us to iterate over a series of increasing values. That's it for now. Next time we'll look at the updated list pattern.